This lesson is on solving literal equations. So in the do now, you're asked to solve for each variable. Remember, we're going to isolate the variable and move everything else over to the other side. So pause the video, do the work, and then start the video again, see how you did. So when we solve for the variable x, we're going to isolate that by moving anything next to it over to the other side. Instead of a positive 8, we have a negative 8. We did that to the other side, subtraction property of equality. You got x equals negative 4. When you solved for s over here, I want to isolate s, so I needed to eliminate whatever's right next to it. Instead of multiplying by 4, we divided by 4, and s equals 5. Well, what happens if an equation has more than one variable? We're going to do the same procedure. We're going to use inverse operations. So the inverse of adding is subtracting, the inverse of multiplying is dividing, and we're going to go in reverse order of operations. So if I ask you to solve for x, I need to get rid of adding y. The opposite of adding y, the inverse, is subtracting y. Whatever I do to one side, I do to the other. So I have x, that's a zero pair, equals, and these are not like terms, so I merely write both of them, 4 minus y. Well, what if you're asked to solve for s? Instead of multiplying by 4, we're going to divide by 4. Whatever I do to one side, I do to the other. So p over 4 equals s. Okay, you actually have solved a literal equation. A literal equation has two or more variables, different variables. And when we solve a literal equation, the solution will include at least one variable. So your answer won't simply be a number. It may be a variable or more than one variable. Okay, let's take a look at number 1. If you have a highlighter, it's helpful to highlight what you're solving for. So I have this equation, a equals bh. I'm going to solve for h. If you don't have a highlighter, you can box what you are solving for. So I need h to stay there. Right now, I want to eliminate what's happening right next to it. H is being multiplied by b. So the inverse of multiplying is dividing. Instead of multiplying by b, we'll divide by b. Whatever I do to one side of the equation, I'm going to do to the other. So a over b equals, and b divided by itself is 1, so that equals h. For number 2, I need to solve for L, so either box it or highlight it, and take a look at what's happening next to L. It's being multiplied by W and H. So instead of multiplying by WH, I'm going to divide by them. And whatever I do to one side of the equation, I do to the other. So my answer is V over WH equals L. My answer to this literal equation will have additional variables in it. Okay, for number 3, solve for B. So either highlight or box B and take a look at what's happening next to it. 2a is being added. So instead of adding 2a, I am going to subtract 2a. And whatever I do to one side of the equation, I do to the other to balance it off. Subtraction property of equality. These are not like terms, so this is p minus 2a equals, and a positive 2a and a negative 2a is 0, and that equals b. I have solved for b because b is by itself. How about p equals 2l plus 2w? I need to solve for w. So what's happening next to w? We take a look at PEMDAS. 2l is being added, and w is being multiplied by 2. Remember, when we solve an equation, you go in reverse order of PEMDAS. So I take care of the addition first. Instead of adding 2l, I am subtracting 2L. Whatever I do to one side of the equation, I'm going to do to the other. These are not like terms, so P minus 2L equals 2W. Well, I'm almost there, but I still need to isolate W. And instead of multiplying by 2, I'll divide by 2. Whatever I do to one side, I'll do to the other. So P minus 2L over 2 equals W. I could decide to divide this, but if I did, I have to divide each of these terms by 2. So I could say P over 2 minus L equals W. But if you wanted to leave it like this, you are fine. Okay, let's take a look at this. We are solving for B, so I'm going to highlight B or box it, in terms of V and H. So when it says in terms of V and H, it is saying your final answer will have the variables V and H in it. That's all that means in terms of V and H. Okay, remember how we get rid of a fractional coefficient. That's right, you multiply it by the reciprocal. So the reciprocal of 1/3 is 3 over 1. So 3 over 1 times 1/3 BH. Remember, we're solving for B. So 3 times V is 3V. Over 1 is just 3V. Any number times its reciprocal is 1, so we're left with BH. I need to isolate B. What's happening next to it? It's being multiplied by H. So instead of multiplying by H, I'm going to divide by H. Whatever I do to one side of the equation, I'll do to the other. So I have 3V over H equals B. Okay, let's take a look at number 6. We are going to solve for C in terms of F. So that means my final answer will have F in it. So what's happening next to C? I see multiplication and I see addition. Remember reverse order of operations, we had to take care of the addition first. So I'm going to subtract 32 on both sides. I have F minus 32 equals 9/5 C. And that's a zero pair. Okay, I'm almost there. I need to get C by itself. Well, how do I get rid of a fractional coefficient? Think of what we did in the previous problem. That's right. You multiply by its reciprocal, 5 over 9. Whatever you do to one side, I do to the other. But because this has two terms, I need to put parentheses around it. So all this is on top. So 5 times F minus 32 over 9 equals, and any number times its reciprocal is a 1, so it equals C. Okay, now it's your turn. Stop the video, work on these. If you feel you're getting a little stuck, start the video again to make sure that you're on the right track with this. And if you are doing fine, wait until you finish with number 9 and then check the video and see how you did. Okay, let's take a look at this. The only thing happening next to x was multiplication, and the inverse of multiplying is dividing. So instead of multiplying by a, I will divide by a. I do that on both sides of the equation, division, property of equality. And a divided by a is 1, so this is 1x, equals 7 over a. Over here, here's x. The only thing that's happening next to it is 2a is being added. So the opposite of adding something is subtracting. Subtract 2a from both sides. This is a zero pair. And I have x equals 6 minus 2a. These are not like terms because this has a variable and this is a constant. For C, I'm multiplying and then I'm adding. So we go in reverse order. I take care of the addition. Instead of adding n, I'm going to subtract n on both sides. Ax equals n minus n. And instead of multiplying by a, I'll divide by a. A goes in once, and I'm left with x equals n minus n over a. Okay, let's take a look at this. Solve for t, so you either highlight or box that, in terms of s and g. Well, both of these are being multiplied by t. Let's get rid of the fractional coefficient first. Remember what we did to get rid of it in the previous questions. So I'm going to write this out again, give myself a little bit of room. Instead of multiplying by 1/2, I'm going to multiply by its reciprocal, 2 over 1, and do the same thing over here. So 2 times s is 2s over 1 is 2s. Any number times its reciprocal is 1, and I'm left with gt. Well, now what's happening next to t? This is being multiplied. So instead of multiplying by g, I'm going to divide by g. And I get 2s over g equals, and g divided by g is 1, so equals t. The next one, how do I solve for r? So I'll box r in terms of c and pi. So I know c and pi are going to be in my final answer. Well, when I look at r, I notice that it's being multiplied by 2 and pi. So the opposite of multiplying something is dividing. Instead of multiplying by 2 pi, I'm going to divide by 2 pi. Whatever I do to one side, I'm going to do to the other. So I have c over 2 pi equals, well, 2 pi over 2 pi is 1, so equals r. Okay, let's take a look at the takeaway. To synopsize, how do we solve a literal equation for a given variable? So we're going to use the properties of equality. Whatever you do to one side, you do to the other. In this case, I divided this side by g, and I'm dividing this side by g. Division property of equality. And then imagine that the blank you are not solving for in a literal equation are numbers. So imagine that the variables you are not solving for are actually numbers. Think about it. We're not solving for a here. But remember, if I'm going to add something, the opposite of it would be subtracting. Okay, you have this to watch again. You're going to have an SOS video on literal equations, and you have a flip video that goes over all the types of equations. And Monday is extra help. Looking forward to seeing you there.